Okay, so we are in the middle of understanding how to control the quality of a machine learning embedded system. And in order to do that, we're using the empirical distribution and non-parametric approaches to create control intervals over an unknown distribution using the empirical distribution. In order to do these things, we need to understand the concept of a convergence in distribution, which I'm going to define now and explain a bit using an example. So the formal distribution here is definition 1.1. If you have a sequence of random variables, which they have the distributive function associated with F1, F2, and so on, we say that that sequence converges in distribution to another distribution function F if for every continuous point X in R, the sequence of distributions converges pointwise to the distribution. So two comments about this. One is that a distribution function will be mostly continuous. Just will have some jumps. We'll talk about that in more details later on. But most of the time it's a continuous. At least if we're talking about continuous distribution that has a density. And the type of the way the distribution function will be not continuous is just by a jump. So if you converge, if you have a point that is discontinuous and you're approaching it from the left or from the right, you will get to a limit, but it will be a different limit. Okay? So that's one, and most of the points, when I say most, but a countable set, most of the points will be continuous. For a discrete distribution, you're just going to have all the points being not continuous, but they'll be also countable. Okay, so that's one point. So most of the time for continuous distribution, most of the time but a countable set, you'll be talking about continuous points. And most of the time you'll be talking about convergence there. So what I want to do is go through an example that will explain what I mean by convergence in distribution. So consider this function here, f of n, which is a line. Let's have a look at the example here. So let me close that. So f of n if you only look at f of n at the line from the point that it intersects with the x and the y axis, then you would see that it's a density function because the area there of the triangle is 1. So let's see that concretely. So I'll set that to 1, so we won't execute the inner loop, and I'll ask it to show the line. Okay. So this line that we're going to show now is the limiting distribution. Let's see how it looks. So it's executing, and you see it's a simple, line that goes from -2 to 1. So the area, the triangle area here is 1 times 2 over 2, which is 1. So it's a density function. You define that it's a 0 when you're higher than 0, then the function is 0, and when you're less than -2, the function is 0. This is the limiting function here. Okay, this is the limiting function, and that's what we want to converge to. Now we consider this sequence of densities, which again they look like. Let's see just the first one so we understand what's going on. So the first one, I'll take 2. And I'll run it, but I don't want to. I want to show them at the same. I want to show them together. So let's see what happens. So we have 2 lines. Now this is the limiting. This is the limiting distribution, and this is the first element, which is here. You have n equals 2, and basically that's what you get here. So this is 1 minus a half, and this is a -4. So if you have 4 times a half is a half. No, 4 times a half is 2, times a half is 1. So this is again a density. Okay? And now I'm going to let this density to have using the same rule, but n equals 3 and so and so on. So we get the convergence in distribution. So now when I run it, you get this is half, then 1 over 3, and so on, and the density just converges to the limiting density. And the same with the probability. If you calculate the probability up to now, up to here, up to -1, then that density is going to converge to the density of the limiting distribution, which is exactly what the definition is of convergence in distribution. So this is an example of convergence in distribution. Any questions or comments on this?
No.
Okay. So thank you very much for joining, and we'll continue this next week.
Thank you.
Thank you. Eitan, תעשה stop recording למעלה.